Okay, we're back again. This time we're talking about Unit 2, Lesson 4. This is about the midpoint of a line segment. Okay, this involves the midpoint formula, which, just like the distance formula we talked about before, is also a derivative of the distance, or the Pythagorean theorem. Okay, so let's go ahead and take a look at this. First, in our definitions, we have the midpoint of a line segment. That is the point that is equidistant from both endpoints. So if you have a line segment, it's the one that's directly in the center. Okay? For line segment AB, midpoint M is located such that the length of AM equals the length of MB. Okay? So if you diagram it, this is what you got. The length of AM is equal to the length of MB, because M is the midpoint of line segment AB. Okay, if the line segment is on a number line where the coordinate of point A is simply A and point B is simply B, then you just add those together and divide by 2, and that gives you the average, which is the midpoint. All right, so this would be the midpoint formula for a number line. Okay? Example 1, they want you to find the midpoint of segment PQ. So we have what? P is at 8, Q is at -6. So what we do is we take 8 plus -6 and divide by 2. Or -6 plus 8 divided by 2, same difference. So this gives us 2 over 2, which is equal to 1. So the midpoint of this is going to be right here at coordinate 1. Okay, they want us to find the midpoint of segment AB on the number line where A is at -2 and B is at -22. Once again, put them into the formula, add them together. So this is what we actually have on the number line. So we simply take -2 plus -22 divided by 2. This gives us -24 divided by 2, which is -12. So the midpoint would be at the coordinate -12. Okay, example 3, consider the line segment GH that lies on a number line. G is located at -5 and the midpoint is at 1. What is the coordinate of H? So what they're wanting you to do here is, instead of just taking the 2 and adding them together and finding out what the average is, this time they want you to project from knowing what one endpoint is and what the midpoint is to find the other end point. Okay, so this is the procedure for doing that. So you know that G is at -5, M is here, H is over here at some unknown coordinate. So we plug it into the formula, because this time we know the answer. The answer was 1, so this is equal to -5 plus H divided by 2. So we multiply both sides by 2 to simplify. So the 2 goes away over here. So this gives us 2 times 1, which is 2, is equal to -5 plus H. We're going to take the -5 to the other side by changing it to a +5. So this, we're going to continue up here. So this becomes 2 plus 5 equals H. So 7 is equal to H. So the end point over here would be at point 7. Now consider a line segment that does not lie on a number line. In other words, this is on a Cartesian coordinate system. So this is x1, y1, x2, y2. Okay, our formula for that is what we can still find by averaging, except this time, instead of averaging one pair of coordinates, we have to average both pairs. So to find the x coordinate of the midpoint, we average x1 plus x2 divided by 2. And to find the y coordinate of the midpoint, we take y1 plus y2 divided by 2. Okay? So the midpoint formula then, which you will see on any kind of test that you take, is going to be x1 plus x2 over 2, y1 plus y2 over 2. It is nice that it's written this way, where this is the x of the midpoint and the y of the midpoint, because once again they're going to ask us to project before we're finished with this. And if we understand that concept, then we don't have to do so much work. Okay, it says if point A has coordinates 2, negative 8, and B has the coordinates negative 2, 1, they want you to find the coordinates of the midpoint of segment AB. So we take our formula, which says that x, the midpoint x, is going to equal 2 plus negative 2 divided by 2, which is 0 in this case. Okay, the y of the midpoint is going to be negative 8 plus 1 over 2, which gives us negative 7 over 2. So the midpoint that we're looking for is going to be, in the coordinate way of writing this, is going to be 0, negative 7 over 2. Okay, example 5 says if B has coordinates 4, negative 100, and C has coordinates 6, negative 2, they want the coordinates of the midpoint of BC. Okay, so here's what we got. We got something looks something like this. So we average the x's by taking 6 plus 4, or 4 plus 6 in this case, divided by 2 is equal to 10 over 2 equals 5. The y midpoint coordinate is negative 100 minus 2 over 2 equals negative 102 over 2, which is equal to negative 51. So our coordinates here are going to be 5, negative 51. Okay, example 6. What are the coordinates of point W if the midpoint of segment WV is at 2, 0, and the coordinates of point V are negative 10, 8. So this is the situation we talked about before. What they're asking us to do is they gave us one endpoint and the midpoint coordinates, and they're wanting us to project out what the other endpoint is. Okay, so here's what we have. We have this situation here where we have VW and point M. So we know the coordinates of V are negative 10, 8, and point M are 2, 0. So to project this, we use the same formula, which says that 2 is equal to negative 10 plus the x of point W divided by 2. So this becomes 4 equals negative 10 plus xw by multiplying both sides by 2. Now we're going to transfer the negative 10 over. So this gives us 4 plus 10 equals x coordinate. So this gives us 14 is equal to the x coordinate. Okay, for the y coordinate, we do a similar thing, but this time we know that this is at point 0. So if we have 8 plus the y coordinate of point W divided by 2, we're going to multiply both sides by 2 to get rid of the denominator. So this gives us 0 is equal to 8 plus the y coordinate of W. We're going to move the 8 over. So negative 8 equals the y coordinate of W. So the other endpoint is going to be 14, negative 8. Okay, thank you very much for watching. Be sure you bring any questions you have to class tomorrow and put them on the parking lot. Thank you. Goodbye.